I go to the shops and buy 2 carrots and 3 bananas. In total, my shopping costs me 90 pence. The cost of 1 banana is 20 pence. Work out the cost of 1 carrot. So actually a reasonably straightforward question. So go on then, work out the cost of 1 carrot. But while you are doing that, think about how you have got to that answer. What steps have you taken, and in what order, to actually work out the cost of 1 carrot? But otherwise, go on then, work it out.
This is probably a reasonably simple question, especially because it has this real-world context to it of going shopping. It's something that we can actually picture, something we can imagine, something we can work with. In addition, the numbers are quite small, quite nice numbers, so we can work with them quite easily. We could even grab some coins to help us with this if we wanted. But there's more going on with this question than we might first realise. So what I'm going to do is I'm going to write out a full proper solution. Just bear with me on this because it might get a little bit boring. So if we're doing this properly, well, first of all, we need to establish what it is that we're working with. We need to establish where this total cost of the 90 pence comes from, because that is actually the single most important piece of information in this question, that in total my shopping comes to 90 pence. So we need to have the total cost of the shopping. That's our start point. Total cost of shopping, and that total cost comes from somewhere, and we need to understand where it is that that comes from. Now, we do instinctively understand where that comes from, but probably we should write it out. Well, that total cost of the shopping comes from the cost of the carrots added to the cost of the bananas. The fact that we're adding is not that surprising because we've got that word total, and total means to add. So the total cost of the shopping is the cost of the carrots plus the cost of the bananas. More specifically though, the total cost of the shopping is the cost of the carrots. Well, the cost of the carrots is the cost of 2 carrots. Or rather, it's 2 times the cost of 1 carrot. We have to know what 1 carrot costs, and then we need 2 of them. Same with the bananas. We have to know what 1 banana costs, so we can then work out the total cost of the bananas. That's 3 times the cost of 1 banana. So, the cost of the carrots is 2 times the cost of 1 carrot. And the cost of the bananas is 3 times the cost of 1 banana. Because when we say the cost of carrots, we mean really the cost of 2 carrots and the cost of 3 bananas, which could then be turned into 2 times the cost of 1 carrot plus 3 times the cost of 1 banana. Once we know those 2 numbers, or if we want to find one in the case of the cost of the carrot, after all, that is what we're looking for, we can work out the total cost of the shopping. And those 2 things are still equal to the total cost of the shopping. But in the question, we are given some of this information. Some of it we're left to find for ourselves. That's the whole point of this question. Some of it we are given, though. We are given the total cost of the shopping. We're told that the cost of the shopping is 90 pence. I'm going to keep the units on it just in case at this point, because it's always good to keep track of units through questions. This 90 pence comes from 2 times the cost of 1 carrot. We still don't know what that is. And that gets added to 3 times the cost of 1 banana. Well, we know what 3 times the cost of 1 banana is, because we know what the cost of 1 banana is. So the cost of 1 banana is 20 pence. It's 3 times the 20 pence. We could actually start working with these numbers now. The 90 pence then must be 2 times the cost of 1 carrot added to, well, 3 times the 20 pence, we can actually work that out, so why not? 3 times the 20 pence is 60 pence. The 90 pence comes from the 60 pence from the bananas plus the cost of the carrots, which is 2 times the cost of 1 carrot. So all we need to do then to work out the cost of the carrots is we need to know how much of the 90 pence is coming from the carrots. Well, if 60 pence is coming from the bananas, the rest must be coming from the carrots. That's an extra 30p we'd need. But if we're doing that properly, what we'd be saying is we'd be saying 2 times the cost of 1 carrot is the 90 pence less the 60 pence gives us that 30p difference. But we don't want 2 times the cost of 1 caret. We don't want the cost of all the carrots in total. We just want the cost of 1 caret, and there are 2 of them. So therefore, the cost of 1 caret, what we'll have to do is we'll take that 30p, we'll divide it by 2, share it equally across the 2 carrots, and 30p divided by 2 is 15p, and therefore the cost of 1 caret is 15p. Which surely seems like too much work for a question of this nature. This was quite a simple question, and you probably all did this much quicker than I have just done. And that's because I was writing down every single thing that I did. I was taking this question through a full process, fully written, fully explained, and fully talked through at every step. And actually, a lot of the time we wouldn't need that. There's too much information here for a simple question. It was quite boring. And what made this question so long to do, because actually this is probably the process that you all did, it's just that you did it much quicker. What would help with this question is if we could write this much quicker. And we could start to shorten this a little bit, because we have an innate understanding of what we're talking about while we're doing this question. So what if, instead of writing things like total cost of shopping, well surely actually we could just call that total cost. And that's probably okay. If we understand that when we're writing total cost, what we mean is the total cost of all the shopping. So we could just write out total cost instead, and that's okay. We could probably shorten this a little bit more as well. Maybe rather than write cost of 2 carrots, well actually we could just write 2 carrots. Instead of writing cost of carrots and cost of bananas, we could just write carrots and bananas, where we understand that we're writing the word carrot to mean cost of a carrot. And we can get rid of those as well, so that we can say that 2 carrots and 3 bananas comes to the total cost of the shopping. In fact, we could even get rid of the word cost and just write total if we wanted. That total is the total cost of the shopping, and that comes from 2 carrots and 3 bananas, where we are using the word carrots to really mean the cost of a carrot, and the word bananas to really mean the cost of a banana. Then we have that the total is 2 times the carrot and 3 times the banana, where we're using the word carrot and banana to stand for the monetary values of those. 2 times the cost of 1 carrot, well we still haven't got that, but we're shortening it. 2 times the carrot, and 3 times the 20p now, which is the banana cost. 2 times the carrot plus the 60p, well we've still worked out that 60p, and now we have the 2 times the carrot, where again we're using the word carrot as shorthand to stand for the cost of a carrot, is the 90p less the 60p, comes to 30p, so therefore 1 carrot would simply be the 30p divided by 2 is 15p. Exactly the same working, but much quicker and much shorter. There's much less information on here. It looks much easier to follow. As long as we in our heads know that we are using carrots to stand for cost of a carrot and bananas to stand for cost of a banana, as long as we understand that that is a shorthand that we're using, that's okay to use. But surely, if we are shortening these and using sort of like a code almost, surely we could set up whatever code we wanted. And we could go even further. As long as we understand the code that we've set up, we can use whatever code shorthand we want. So why not, instead of using the word total, just to make it even quicker to write, why don't we just write T, where we understand that T stands for total, which is short for total cost of the shopping. And if we're doing that, well, we know that we're talking about carrots and bananas, and it's very helpful that carrots and bananas start with different letters, because surely we could just use C for carrots and B for bananas. Well, we could do, certainly, if we wanted. It's our code. We could use anything. We could use T for carrots and A for bananas if we wanted, because carrot ends with a T and banana ends with an A. We wouldn't. It would seem like a stupid thing to do. C for carrots and B for bananas would seem sensible, where C stands for carrot, which stands for cost of a carrot, and B stands for banana, which stands for the cost of a banana. And we're okay to do that. And if we use that code all the way through, I'm going to do that question again, and I'm going to talk over it while I write it down, So let's clear what we've done. And let's do that question again with the new code in place. So I go to the shops and I buy 2 carrots and 3 bananas. In total, my shopping comes to 90 pence. The bananas cost 20 pence each. Work out the cost of 1 carrot. So the total of the shopping is 2 lots of the carrots and 3 bananas added together. 2 carrots and 3 bananas added together gives us the total, where C is carrot and B is banana. Fine. The total is 90 pence. Which is still 2 lots of the carrots. We don't know the cost of the carrots, but we do know the cost of the bananas. B for banana, which is short for the cost of a banana. And that will come from 3 times the 20 pence there. 90 pence is 2 times the cost of the carrot, where C is short for carrot, which is short for cost of the carrot, plus the 60 pence there, 3 times the 20 pence. 2 times the cost of the carrot, that's the cost of 2 carrots, in fact, is 90 pence less the 60 pence to give us that 30 pence difference there. 30 pence contribution from the 2 carrots. We know the price of 2 carrots now. We don't want the price of 2 carrots, we want the price of 1 carrot. So the price of 1 carrot, that's C for carrot, must be the 30 pence divided by 2 is 15 pence. And the cost of 1 carrot, C, short for carrot, short for the cost of a carrot, is 15 pence. And that was much quicker to do. And at this point, you have probably worked out what we are talking about now, because this should remind you of something dreaded, something we don't like doing, something that brings back bad memories, quite possibly. Yes, we are going to have to look at it. And we're on this for a few weeks now, so get used to it. We are having a look at yes, algebra. But you have just done algebra. There is a common misconception that algebra is this: weird letters turning up. But actually, algebra is not. What algebra is taking information that you know and using it to find information that you don't know. Exactly what we've just done. You took some information you knew, the total cost of the shopping and the cost of 1 banana, and you went through a logical process to find a piece of information that you didn't know. That's the cost of the carrot. And that is what algebra is. Algebra is just logical problem solving. To help us do that, yes, we do introduce letters, but all the letters are, exactly like we've just done, is a code. We're using the letter T to stand for total, because it makes sense as a code. We're using C to stand for carrots, or the cost of a carrot, because that makes sense as a code. We're using B to stand for banana, or the cost of a banana, because that makes sense as a code. Algebra does use letters, but it uses letters as a code, a shorthand, a way of writing information that we either do know and are going to swap in later, or information that we don't know and are going to find out later. The choice of letter here was completely arbitrary. We could have used any letters we wanted. It's just that T and C and B made sense because they are the start letters of the words. As I said before, we could have used T for carrot and we could have used A for banana, because carrot and banana end in T and A. They just don't make sense to use those letters. So algebra, all it is a problem-solving setup where we take information that we know and information that we don't know and work from one to the other. Take something we know and use that to help us find something that we don't know through a logical set of steps. But we do have to use letters, and these letters are just code. Sometimes the letters are code for a piece of information, a number, for example, that we do know. Like here we had B standing for 20p, because B was the cost of the bananas. We knew what that was. T stood for the 90 pence, because we did know what that was. Or sometimes the letters might stand for things we don't know, like the C in this case. The C stood for a piece of information that we didn't know, but by the time we got to the end of the question, we had worked it out. The key thing to take away from this is that if you got down to the 15p at the end of this question, however you did it, you have answered an algebra question. You maybe just didn't realise you had done. Right, the basics. Letters are a helpful substitute. Now actually, because they are just a code, the choice to use letters is also completely arbitrary. Not only does it not generally matter what letter we use, it doesn't actually necessarily have to be letters. All algebra is using something to code for information that we either know or don't know and want to find out. It could be a word that we're using. Using the word carrot is also us using this process of algebra. So if it helps, whenever you see letters in algebra questions, it will tend to be letters in algebra questions. It's the most useful shorthand to use. But if it helps, whenever you see letters in algebra questions, you could always swap them out for a word beginning with that, if that makes more sense to you. You could use pictures as code. Algebra would still work just as well with pictures. You could use a picture of a smiley face to code for one particular piece of information, and a picture of a frowny face to code for another piece of information. It's just that we tend to stick with letters because they are the easiest code to use. Nice and easy to write down. We've got a lot of choice from them. There's 26 to choose from. And I suppose you could also introduce Greek letters as well if you wanted, or that kind of thing, which in fact we have already seen. Remember when we had that number pi from the circle at 3.141592653, that number that was so very long, the number of times the diameter of a circle would fit around the outside if we stretched it? Well, that was us using a form of algebra and giving that number a name and using that Greek letter. That is us using code for a particular piece of information. The particular piece of information in that case being the number 3.1415 and so on. We just give it a name, and the name we use happens to be that Greek letter pi to make it easier to write down. And that's kind of all this is. It's just us using letters as a quick shorthand. The choice of letter is completely arbitrary. You could pick any letter you wanted. There are certain letters that will get used quite a lot in exams. In some situations it does matter more, in some it doesn't. But letters that will be used in the exams quite a lot. You might well see questions using A, B and C. You might well see questions using things like P, Q, R and S. Just because they're good kind of sets of letters. You might see a T, but they will often use T for time. T is not exclusively used for time or units of time, like a certain number of seconds or a certain number of hours, say, but it's often used for time, which kind of makes sense as a code. But just because T is there doesn't mean it is a time, and just because a time is mentioned doesn't mean it will be using T. You could have H for the number of hours, say. We also tend to see X, Y and Z, and I want to make a point about this. X, Y and Z. Point number one to make about this. This way of writing X is an algebra notation thing. Whenever we write an X in algebra, we write it with this curly X kind of idea. Because if I write an X like that, is that an X, as in the letter X, or is that a times symbol? And things start to get confusing, because if we wanted, say, two lots of this number X, if I wrote that, that is already quite confusing. Whereas that is clearly 2 times this piece of information X. So we write X in this curly way. So this X with the curly is an algebra notation. And this is important. You will not be penalised if you don't write the X with curls, but it is much easier if you do, and you have to be aware that the exam and things will use that curly X. This, however, this Z with a crossbar, is not algebra notation, that is just my handwriting. So you are allowed to write down Zs however you wish, but I would say if your Zs look a little bit like 2s, maybe put the crossbar on the Zs to make clear that it's a Z and not a 2. That's the only reason I do it, to be honest. But we could and will see any letter at all. Key thing though, whenever we see an algebra question and we are talking about particular letters, each letter is code for a particular number. We might know what that number is, we might be told in the question, or we might have a way of working it out, or it might be something that we need to find as part of the question. Or, sometimes, we might never actually find out. We might be working with the letter and manipulating it in some way, we're going to see how very shortly, but we might never find out the identity of that letter. We might never find out what number that is code for, but it is always worth remembering that any letter is code for a number that we will either find out or know or not ever know. Two final pieces of terminology before we've covered the very basics, and then we can start to actually look at how this stuff works. Here is a piece of algebra. It doesn't really matter what this means just at the moment, but here is a particular piece of algebra. Now that piece of algebra just sits there on its own. It's not doing anything. There is nothing we can do with that at all without more information. This is an expression. And we talk about an algebraic expression or an expression in algebra, and we just mean a piece of algebra that just sits there. It doesn't really mean anything on its own. It's probably come from somewhere. It might have come from somewhere. It's just a piece of algebra. There's nothing we could do with that without some more information. But I could take the same piece of algebra and I could now tell you that it is equal to 10, for example. Now, as soon as I've put that equals sign in there, as soon as that symbol has appeared, I have told you a bit more information about this. And this, we'll eventually see, is enough information to be able to work out what number that letter X is code for. And as soon as you take a piece of algebra and you set it equal to something, it becomes not an expression, but an equation. And an equation can be worked with. And we're going to come back to these ideas through the next few lessons.